Go ahead.
Terrific. Good morning, everybody. Welcome to session 2 of our virtual EnviroTech. Nice to have everybody online. Of course, we'd all prefer to see each other in person, but kudos to Joe and the ESA team for putting this together. For those of you who watched session 1 earlier this morning, hope you enjoyed it. I think we have a really interesting lineup here for the next couple of hours coming up. Hopefully you can see on your screen the 4 topics that Brody, Jeff, Anthony, and Danny are going to be covering in the next half hour or so. They all relate to greenhouse gas management, climate change, and frankly, quite a diverse group of topics that hopefully will pique everybody's interest. My name's Anand Srivastava. I'm an environmental lawyer at Holmes & Shire Environmental Lawyers, and I'll be moderating this panel, walking us through asking your questions of Brody, Jeff, Anthony, and Danny, respectively. We have 2 hours set aside, and I'd ask the speakers to try to limit themselves to about 25 minutes, which should leave about 5 minutes after each speaker for questions that are specific to that speaker. Enough from me. Let me toss it over to Brody, and Brody is going to tell us about GHG SAT's latest advancements.
Let's see how I'm doing here. Are you able to see the screen there?
Yes. Yes, we can, Brody.
Excellent. Perfect. Okay, I apologize. I'm new to this platform, so just making sure it's all coming up all right there. Yeah, first of all, I guess a thank you to moderators, to EnviroTech. Like you said, we've got to about 25 minutes here. I'll try and keep it to 20 because oftentimes there's lots of interesting and questions that come up, and that's my favorite part as well. So I'll try and get through this quickly, but also with a certain element of thoroughness so that it all fits together. And I am presenting on behalf of Warren Shaw, who luckily is deployed in our aircraft instrument at the with our aircraft instrument at the moment. So thanks to him as well for putting this together. But so today I think we want to talk about at least in terms of GHG SAT, and we did present last year at EnviroTech. Is the latest updates on what we've been doing. And so just jumping right into it, GHG SAT today, we're very much focused on monitoring methane emissions, and we're doing this using our own instruments and our own algorithms. So almost a little self-contained measurement capability here. Last year, the presentation, if you happen to see it, we were a little more focused on our technology. And what it came with today is a little more centered around some of the other developments that we have going on. Full disclosure, we had hoped to have some results from our new satellite available, but unfortunately we don't. I'll get into that in just a moment, but there is some good news at the end. So instead, like I said, a little bit more focus on the scope of some of our other capabilities. And as you can see on the screen here, we have a focus that lies between analytics and then our own satellite and aircraft-based platforms. But before I get too into those, maybe just a quick note on why measure methane emissions in the first place to sort of set the stage. And so first of all, we like to talk about economics. I think in most of these types of discussions, obviously, if you're in an oil and gas type environment, or even you can capture the gas and put it into a usable system and sell it. But there's also other applications. Things like landfills are looking to capture gas from their landfills and either use it for injection or sometimes to power their vehicles. Applications in agriculture, or even in some cases there's business centered around carbon credit generation. So there's a whole bunch of different economic aspects to why you might want to measure methane emissions. Further to that, and on that same theme, is the idea of investors. So when we talk about large capital projects, oftentimes there is an increasing pressure for more disclosures as they relate to risks relating to carbon intensity and that type of thing. up front. And so that could be another reason. And third, is health and safety. Unfortunately, every year there are events that happen where people die because of natural gas explosions, whether it be in leakage into a basement in a rural area or say a coal mine explosion. And the third idea about why we might want to measure deals more with regulations and the idea of where there's taxes and levies being applied in industry. There's certain value in actually making a measurement rather than say using an inventory-based approach to determining what emissions are. So the follow-up to that is, why would we want to measure remotely? So measuring is one thing, but measuring remotely is something else. And so, first thing that comes to mind is the idea of economies of scale. And so at GHG Sat, as the name implies, we do have some satellites available to us to make these measurements, but we also have an airborne platform. And so across these multiple platforms, for instance, an aircraft could monitor hundreds of sites within a day, for instance, whereas a satellite, may be able to make multiple measurements anywhere in the world. And so there's some geographic advantages and trade-offs that need to be made there. But then we also have the analytics, which can provide really, 100% coverage of quite a large area, albeit at a coarser resolution. And so that economies of scale really plays into the idea of this remote measurement capability. Further to that is the idea of ease of deployment. In light of COVID, I think it's fair to say that ease of deployment is certainly a forefront in people's mind when it comes to mobilizing people on the ground and deploying assets. Being remote gives us the ability to do these things, from our homes or basements, in my case today, and allows us to be as close as we can to on-site, as often as needed. Thirdly is the performance, and I kind of touched on that earlier with the idea of, whether we're using inventories or other approaches to detect emissions. So I'll kind of skip that one. And the last idea here is really that of consistency and transparency. So we're using the same technology and approach across our satellite and aircraft platforms to make these measurements, and that allows for real-time or quasi-real-time, I guess I should say, performance benchmarking between sites and between industries. So with that, I'll get into a little bit more of the fun stuff here. If I can advance this. And what you see here in front of you is a quick picture of our demonstration satellite on the right-hand side of the screen. That is Claire. So all of our satellites are named after our employees' children with a vision towards the future. And then on the left-hand side, what you can see there, there's a red circle on the leftmost image. That's highlighting our satellite as it is attached to the launch vehicle. So this demonstration satellite, hence the D for GHG Sat D, was launched in 2016. It weighs about 15 kilograms, and it's about the size of a microwave oven, just to give you a sense for what that is. And so moving on from this, there's the satellite, but how does it actually work? And so I've got a quick animation here. Hopefully this plays appropriately. But we launched our satellite into about a 500 kilometers in altitude orbit that runs north-south around the Earth. And you can kind of think of it as running north-south as the Earth spins west to east underneath it. And what that means is it gives us access with the satellite, at least, to anywhere in the world once every 14 days or thereabouts on average. It depends a bit on where you are on the Earth, but once every 14 days is a good estimate. And so with that capability, as we travel overhead of a particular site, we take basically a 20-second exposure image, you can think of it that way, and we capture a 12 by 12 kilometer area over that site of interest. And the basic premise here is that of spectroscopy, the science that we're using, and we're using naturally reflected sunlight off the surface of the Earth, so it's a completely passive system. But what really sets us apart in some ways is our resolution. So GHG Sat is able to attribute emissions to specific facilities, and with our demonstration satellites, we're at about a 50 meter or better pixel resolution, and then with the follow-on satellites, we'll actually be improving that to 25 meters. I won't get too into the specifics of how it works, but happy to answer questions on that as we go, just in the interest of time. But what I will say is all the images, and I'll show some examples in just a moment, that we have here, all use sort of a differential approach. And what that means is that we take the average background level and we subtract it from the image that we have, and that leaves us with what the enhancements are. And then we're able to attribute those enhancements to particular facilities that we can see on the ground. And so that same principle is also used by our aircraft platform. again, using spectroscopy. The slide here highlights a few differences between the two. A key one being sort of the deployment. So the aircraft flies at around 3 kilometers or 10,000 feet, and is designed, loosely speaking, to cover the same field of view that's captured in a single image from the satellite over the course of a day. Some key advantages, of course, of the aircraft that we're now able to capture methane imagery at a spatial resolution of less than a meter. So extremely high spatial resolution with the airborne sensor. And we have some exciting results I can show you from that as well as we go forward. And I won't go through all of it on here, but I will make a quick note of the two percentages you see at the bottom of the left and right columns relating to the satellite and airborne sensors there. 50% by volume is really referring to, of the total emissions that we see globally, the satellite should be able to detect about 50% of the emissions by volume as it stands. And then the aircraft, that jumps to 90% based on that improved detection capability. So what do those fields of view look like, pictorially? I'll throw something up here for you to take a look at. What you're looking at there is in red is roughly the area that the satellite would see. And then the green box is you can think of it as basically a lawnmower pattern, for lack of a better explanation, but that's set up over the Duvernay. And again, that was just arbitrary to give it a sense. But the idea there is that the aircraft sort of passes line by line over the area of interest and is able to survey, in this particular case, all of these oil and gas facilities over about the course of the day, like I said, and the satellite is able to capture that same space, but not necessarily at the same resolution. And so while they're both looking for methane, they may be seeing different emission sizes, as well as giving us different spatial resolution of those capabilities. So now that I've kind of gone over those two sensors, I want to show a couple examples from them. And the first example that I've got here is these are GHG SAT-D early examples that we have. And so what you're looking at here on the left side of the screen, we're looking down at the surface of the Earth from the satellite. And it's in black and white because that is the shortwave infrared that's bouncing back up to our camera. You'll see there's an inset image, and that's actually the San Juan underground coal mine in the United States. And what we're looking at there is the ventilated air methane that's coming out of that mine. So they vent the methane from the underground mine for health and safety purposes, to avoid explosions and that type of thing. I think that's probably relatively intuitive. The example on the right, though, is a little different. This is maybe unexpected for some, but this is actually a hydroelectric facility. And the dark area you see there, sort of extending from the center towards the bottom right, is the reservoir, and the water flow is going from the bottom right to the top left, loosely speaking, in that image. But the mechanism that takes place here is we have anaerobic decomposition of organic materials that collect in the bottom of reservoirs in some cases. And as that breakdown happens, the methane is released through that anaerobic breakdown, but it is then absorbed by the water in the reservoir. And so what we're seeing, that highlighted hotspot, if you will, of methane concentration is actually downstream. And that's seen downstream in the spillway. So when they spill the water out of the dam, that actually causes the water to degas. And we're able, in some cases, to measure those emissions. And the reality is that actually, in some cases, those methane emissions that come from degassing can exceed the total carbon footprint of actually building the entire hydro facility, again, depending on amount of concrete, geography, and some other factors. But a little bit of an unexpected one there, at least for me. I remember seeing that when I started, but very interesting nonetheless. So these are from early days of GHG SAT-D. A couple more quick examples, and these are just a little more recent. On the left here, again, is a oil and gas facility. This one's in the Permian Basin. And if I'm not mistaken, I believe this one that we have on the left is actually a compressor station that we found that was leaking some methane, and we were able to contact the operator about that. And then on the right-hand side, actually, we have a landfill. So this is a landfill in Asia, a very large landfill. It doesn't have any gas extraction system, and we don't, or if it does, we don't believe it's active at this time. But we are able to also see some landfill methane emissions these are often sort of coincide with emissions of odors and those types of complaints. So there's sort of parallel capabilities that we're able to explore within the landfill sector as well there. Now, I also mentioned the aircraft, and this one is kind of extra exciting for us. Our aircraft is based in Calgary and deployed out of just south of Calgary, out of High River. And what we have here is a very recent observation that we made with our aircraft sensor. This was a controlled release activity that we did just in March. So these are some of the latest results, and this is the first image we've made publicly available from that. And the reason why I gave it a whole slide isn't because I'm most excited about it. It's really more to do with the idea that I want, hopefully, everyone's able to see, the significant difference in resolution. So that sub-meter pixel resolution, really shows up in this particular case, and you can see the plume emanating from the source. As well, I should mention that this emission is more than 100 times smaller than any of those emissions that we've seen with the satellites. And so as we go forward with our aircraft, we'll be seeing more and more of these smaller emissions. And further adding to that encouragement from this activity is that this was done under less than favorable lighting conditions. And like I said, our systems are completely passive, which makes them very safe. But it also means we are subject to some environmental constraints. So it's great to see that we're performing, as well or better than we expected in those conditions, a few months ago. So with all the sensors, that's great that we've got that. So what's next? And what's next for us is deployment. And so, like I said earlier, we'd hope to share results from GHG Sat C1 as part of this presentation. Unfortunately, that satellite has not yet launched. We had a combination of a rocket failure just ahead of us that delayed us, and then we had, unfortunately, COVID, which caused a further delay. But the good news is our launch is scheduled for next Thursday. So it's very close, and we're super excited about it. I do have links and all sorts of fun stuff available for folks if anyone's interested in actually watching that real time or after. So that satellite's ready to go. It's in French Guiana. Ready to launch. The next satellite, Hugo, and again, we're sticking with the theme of naming after our children here, is going to launch in 2020. It's almost complete, but the key part here is both these satellites have really learned a lot from our demo satellites. Again, improvements in resolution and detection threshold being key. And where I started as well was with the aircraft. And so our aircraft today is actually out in the BC Montney on one of its first deployments. We did our first flights back in December, but this is one of our first deployments for the aircraft. And like I said earlier, it's got even better detection capabilities than those satellites, of course, with the trade-off of getting it to the site and operating costs. But that's only two of the three things that I've mentioned. If you remember early on, I talked about analytics. And so I want to change gears just a little bit here and show quickly what we're doing with some of the analytics. The theme here being that, we want to address what's the latest in measurement technology. And one of the things we're doing at GHG Sat now is we're applying these analytics, to sort of build out, if you want to think of it as the third leg of the stool, to use an overused analogy. But the idea here is that with a few examples here, I can show you some of the things that we're doing with analytics. And so what you have in front of you here are three coal mine vents from left to right in each of those images. And what we did was we observed these coal mines over the course of about a 2-year window with GHG Sat D, with the demonstration satellites. And then we took those images and what we do is we sort of average them together. You can think of it that first. And we also rotate for the wind direction so that the wind directions all line up. And so by convention, the wind direction in all of these is coming from north to south. And you can think if we took these 20 images and we put them together, what that allows us to do is it allows us to tease out smaller enhancements of methane concentration on sort of an annualized basis. And it also allows us to reduce the background noise. And so with that, what we're able to do is then determine estimates, at least measured estimates of lower emissions rates than we can detect in a single pass, as well as determine hopefully within reason what the actual emissions rates of certain facilities are over the course of a year. Now, if an individual emission was large enough, we would be able to just take a picture and do that same technique, some reverse plume modeling to determine emissions rates. But what's unique here is this idea of taking multiple images and putting them together to get this information. And so this technique is applicable not only to coal mine vents, but it could certainly be applicable to landfills or other sources, that we might be interested in examining as we go forward. Now, that's one of the analytics examples. Maybe a more recent one and more exciting one to talk about is this year. So, these analytics allow us to provide coverage over very large areas at high frequency with the trade-off of spatial resolution. And so one of the things we're doing is looking at data that's publicly available. And in this case, what we have actually is methane concentration maps that are averaged over a couple months on the left-hand side. So you see there's two images there. This is its whole own article that I've stolen this from that was recently published, but it is interesting nonetheless. So we're looking at March-April timeframe of 2019, and we're looking at in the leftmost image there. And those are the methane concentrations as measured by a European Space Agency instrument called TRPOMI. And that TRPOMI instrument is able to capture, has the potential to capture the whole world once a day. The difference there is that the pixel size is roughly 7 kilometers by 7 kilometers. So it's relatively coarse resolution, but it's giving us very regular intervals. And so we can take that publicly available data and put it together and do some interesting things. And in this particular case, this article talks about, how is COVID impacting methane emissions? And I'll let people go read it if they're interested. But you can certainly see that there's certainly higher concentrations in the right center image than there is on the left as we compare between the 2019 and 2020. But this leads to the next part of the analytics, which is we can use things like this, such as publicly available concentration maps, to steer the satellite. And so in this case, we're able to investigate with GHG-SAT-D within those regions and with that 50-meter spatial resolution. And we were actually able to detect some methane emissions there. And again, we're working with those operators, who may be involved with those emissions. But it doesn't stop there. So there's more we can do than just take publicly available concentration data. So to sort of round out this idea is that what we can do is we can ingest all sorts of publicly available data. And that could include things like visual change detection, weather, flaring, production data, locations of sites, infrastructure, all that type of thing. And we can put that into our analytics engine to make intelligent predictions about where to target our satellite. And so an image that you see up in front of you right now, you can see there's a series of red squares sort of distributed throughout the image, but applying some of the algorithms and capabilities we've developed in-house, you'll see right in the center there's a push pin that says plume. And so we had estimated that there was a good chance that we would find something there if we took a look. And so as I'm sure you can imagine, when we took a look, sure enough, we were able to find what we believe was actually an unlit flare in that particular case. And so really how this all comes together is it allows us to look from a different perspective at methane emissions, like I said, over a very large area at a coarse resolution with high frequency, and then apply that to our fine spatial resolution satellites, and also apply it to even finer aircraft resolution, at which we can then deploy on an as-needed basis. And so overall, what this builds for us is a tiered approach that we can apply across a bunch of different industrial sectors, especially as the analytics continue to improve with the learnings that we have as we implement this. In particular, at the moment, these analytics are of considerable interest to regulatory bodies, as well as to industry when they're managing a large number of assets that are spatially distributed. So I think I'm pretty close on time here. So what I'll leave you with, and hopefully everyone's found this unique approach and capability interesting, and I look forward very much to any questions or comments you might have. But I'll leave you here with a quick set of examples of things we're either doing or looking at doing across 5 of the verticals. There are other areas that we're looking at, but these are sort of 5 key ones. And I'm happy to provide any details on launches or papers or anything else. Feel free to reach out by email. So with that, I guess I'll turn it back over.
Thanks, Brody. Very, very interesting. And if anybody has any questions, please feel free to type into your questions box. I do have a couple for you, Brody, that have come in
Okay.
so far. What's the best time of year to have methane emissions measured, and does that change whether it's captured by the satellite or by the airplane? Are there any weather constraints?
So there are weather constraints. So like I said, because we're passive, we're not able to take imagery through things like clouds. So generally, times where there are fewer clouds are better. Also, the sun angle can play a role, especially when you get to really high and low latitudes on the Earth. So ideally, you want to be in the summer where there's no clouds, if you had to pick the perfect conditions. But as the resolution goes up, you can do things like look between the clouds at the pixels that are cloud-free from the satellite, or in the case of aircraft, you can schedule your deployment to either literally fly around the clouds to avoid them, or fly on a different day. So there are ways to mitigate that as well.
Thanks. Very interesting. And another question that's come in is a question about whether there's any ability to detect methane inside buildings or structures, or must that methane be released into the atmosphere for it to be picked up?
We need it to be available, line of sight. You want to think of it that way in terms of seeing that infrared spectrum reflected back off the surface of the Earth in order for us to measure it. So these are definitely, to be deployed outside, I guess, is probably the best way to characterize it.
Terrific. Thanks, Brody.
Awesome.
I haven't seen any other questions come in, so thank you very much for the insight, and very exciting to see how fine you're able to start collecting this data, and look forward to an update in the future about the 2 new satellites, and perhaps the increasing quality of data that you're able to continue to get.
For sure.
I'm going to stop you there and transition over to Jeff. Jeff's at Tree Time Services, and Jeff is going to give us an update about reforestation, especially in our changing and perhaps uncertain climate. Jeff, we have your screen. Can you see or hear us, Jeff? Jeff, is it possible you're on mute?
Yeah, Jeff, you might be muted.
Jeff, we can see you advancing your slide, but we can't hear you. If there's any chance you could investigate whether you're muted, that'd be great. If not, perhaps we have a small technical glitch.
I'm gonna try giving them a shout.
Thanks, Joe. Good idea. Do you?
Why don't we go to Anthony's present? Why don't we go to the next presentation, and we'll circle back to Jeff?
Sounds good, Anthony. Hope you didn't grab a coffee. If you don't mind, Anthony, we're gonna toss it over to you, and we'll come back to Jeff technology permitting. So let's switch gears a little bit. And before we hear about reforestation, Anthony's going to talk to us about the tier regulation and specifically with its application to the aggregate sector. Anthony's at North Shore. Anthony, can you see and hear us, and likewise?
Yes, I can hear you. I don't know if I'm showing my screen yet, though.
Yes, I believe we can see your screen. If you're able to toss that into a full screen mode, that would be great. We can kind of see the balance of your screen at the moment.
How's that? Is that better?
That's pretty good. We can see your speaking notes. If you'd prefer to hide those, you might consider a presentation mode. But I'll get myself off the screen, and that'll certainly increase the size for everybody else.
Certainly. Just and then what do you see now? Still the speaking notes, or do you see the full screen?
I still see the speaking notes at the bottom of your screen and the slide previews on the left-hand side.
And I'll just go to next, when we're done with Anthony, go back to Jeff.
Perfect. Thanks, Joe.
Yeah.
Anthony, likewise, if you're comfortable with this view, we can see, I think, your notes, but I'll get my my head out of here and I'll turn it over to you.
Sure, that's no problem. I just need to adjust. Is everything still okay here?
Yes, you've gone a little bit off the screen with your slides, but if you pull them a little bit to the right, there you go. That looks good. A little bit better on my end.
Yeah, that's fine with your notes up.
Okay, perfect. Thank you. So thank you, EnviroTech and Anand, for moderating here. Unfortunately, I can't seem to figure out the technical difficulty here, so you'll have to read my speaking notes as I go along. My name is Anthony Pham, and I'll be presenting on the Alberta Technology Innovation and Emissions Reduction Regulation, also known as the TIER regulation, with a specific focus on aggregate facilities. As a general overview, TIER became effective as of this year, and it applies to facilities emitting more than 100,000 tons of greenhouse gas in the form of carbon dioxide equivalent per year. It requires the facility to reduce emissions based on either a facility-specific benchmark approach or a high-performance benchmark approach, whichever is the least stringent. There's 3 opt-in options for facilities, whether the facility competes against a regulated facility, whether the facility belongs to a trade-exposed sector with emissions greater than 10,000 tons, and whether the facility would like to opt in as an aggregate facility, which is the focus of today's presentation. So an aggregate facility under the regulation is 2 or more small facilities that meet the conventional oil and gas definition and is treated as a single facility under the regulation. The regulated emission sources only include stationary combustion emissions only, and the facility is required to adhere to an emission intensity reduction requirement of 10% or a facility-specific benchmarking of 90% of historical emissions with 2020 as the reference year. The emissions intensity is not subject to an annual tightening rate, and a high performance benchmark may be applicable in the near future and subject to the least stringent approach. So you might ask yourself, why would a company decide to opt in as an aggregate facility? The reason is, under the Greenhouse Gas Pollution Pricing Act, the Government of Canada applied the federal fuel charge in Alberta starting this year, and this translates into a fuel charge of $30 a ton on all fuels. And specifically for natural gas, this equates to 5.87 cents per meter cubed. However, facilities regulated under the TIER regulation meet the federal exemption, and TIER regulated facilities are protected from the full cost of complying with the federal act, as long as the facility complies with the TIER regulation. It should be noted that the tier meets federal equivalency because the compliance cost for both programs is set at $30 a ton in 2020. And to meet the federal exemption for 2021, the compliance cost for tier will have to increase to $40 a ton to keep pace with the federal act. As I mentioned, a regulated facility is protected from the Greenhouse Gas Pollution Pricing Act as long as it adheres to the tier regulation. And the aggregated facility is required to maintain an emissions intensity reduction requirement of 10%. The reference years for the aggregate facility will be 2020 and the 2020 compliance year. And Alberta Environment Parks recently discussed that the reference years to be used are still to be decided. However, it is anticipated that the 2021 compliance year will be the 2-year average of 2020 and 2021. And for the 2022 compliance year and onward, it will be the 3-year average of 2020 to 2022. And if, for example, a company has already significantly invested in their assets for the purpose of emissions reduction, and believe 2019 would be a more suitable reference year, the company can apply to use 2019 as the reference year. I have an opt-in example for a company interested in opting into the tier program as an aggregate facility. A few facts about this company. During 2020, the company operated 79 facilities and consumed 187,000 decks of natural gas. With a fuel charge of 5.87 cents per meter cubed, under the Greenhouse Gas Pollution Pricing Act, the facility will have to pay just under $11 million. And to compare with the tier program, we'll look at the production metrics for this company. And so for during 2020, the company produced an equivalent gas product of just over 2.3 million decks of natural gas. And to produce that much product, the facility emitted 484,000 tons of carbon dioxide equivalent from stationary combustion emissions only, producing an emissions intensity of roughly 0.2. And you may recall that the 2020 compliance year will also have a facility-specific reference year of 2020, with the reduction target set at 10% of the facility-specific benchmark, or 90% of historical emissions. Then the emissions reduction obligation is 0.18. And to meet this obligation, the facility must reduce emissions by approximately 48,000 tons. And after applying the true-up obligation of $30 a ton, the facility will have a compliance payment of roughly $1.4 million. So to recap, under the federal fuel charge option under the Greenhouse Gas Pollution Pricing Act, the facility may have to pay $11 million, but by opting in as a tier aggregate facility, the facility would only pay 1.4 for a grand difference of $9.5 million. So whether a company should opt in as a tier aggregate facility really boils down to the specific circumstances of the company. So it would be ideal if the company, if they had multiple facilities, as the reporting and verification is simplified, it reduces administrative costs, compliance costs. But if the company is small with not many facilities, this example may not be good, as reporting and verification may cost more than the example provided. The rest of this presentation will focus on the draft quantification methodologies released by Alberta Environment Parks on May 29th of this year. AEP also included a few announcements, including a change to the benchmark year for conventional oil and gas facilities from 2019 to 2020. And regulated facilities are advised not to prepare and submit a tier benchmark application this year, as next year will serve this purpose. And the compliance and benchmark submission deadline is to be formally announced at a later date. Also, the commenting form for the draft quantification methodology can be found at the link shown, and the commenting period started on May 29th and runs until June 4th. So Chapter 15 of the Greenhouse Gas Quantification Methodology prescribes methodologies for aggregate facilities. And as I mentioned before, an aggregated facility consists of 2 or more conventional oil and gas facilities, abbreviated here as a COG. Regulated emissions only include stationary fuel combustion and is compared to the total production volumes for both the benchmarking and compliance reporting. And multiple sites may be integrated in operation and be identified as a single cog within an aggregate facility, provided the integrated site emits less than 100,000 tons of carbon dioxide equivalent. So say, for example, you have 100 integrated sites consisting of a gas plant, a battery, a gas gathering system, and multiple wells. It may be easier to identify those sites as a single cog for the purpose of estimating emissions. Or as another example, you have 200 integrated sites and their combined emissions are greater than 10,000 tons. You may identify that group as a separate cog, as the emission methodologies may be different in other groups. Keeping in mind that the cog emission limit is 100,000 tons of carbon dioxide equivalent, and there is no limit for the aggregate facility. The quantification methodology document provides estimation methods for the following parameters: fuel consumption volumes, carbon dioxide emissions, methane and nitrous oxide emissions, and Petronex production volumes. The quantification methodologies in this chapter are classified by levels of stringency and accuracy, with the lowest at level 0 and the highest at level 1. The minimum levels required to use for both benchmarking and compliance reporting are provided in Alberta's standard for developing benchmarks and the standard for completing greenhouse gas compliance and forecasting reports. For fuel consumption and carbon dioxide emission methods, COGs that have emissions greater than 10,000 tons may use the methods that are classified as level 0 or higher, and COGs that have emissions greater than 10,000 tons may use methods that are classified as level 1 or higher. The methods that are selected for the COGs within the aggregates facility must be used for both benchmark and compliance reporting. Fuel consumption and composition, method 1, also known as the single fuel gas stream approach. This method is for an individual COG with emissions less than 10,000 tons. And the fuel gas reported in the Petronex system may be assumed to have the same gas composition. And for these volumes, a carbon dioxide emission factor is based on a rich gas composition would be applied to calculate the emissions. Method 2, a multiple fuel gas stream approach. While all COGs may use this method, COG facilities with emissions greater than 10,000 tons of carbon dioxide equivalent are required to maintain fuel consumption totals for each type of fuel gas consumed. As the fuel gas quantities reported in Petronex are not differentiated by gas compositions, the facility must demonstrate the separation of fuel gas streams based on metered volumes and representative gas analysis. The average gas composition of the reporting period or higher heating value must be calculated using a weighted average approach, keeping in mind that the federal ECCC greenhouse gas reporting program requires at least 2 semi-annual analyses for marketable natural gas and weekly for non-marketable natural gas. There's been some discussion with oil and gas companies that for weekly sampling, the sampling rate is a bit unreasonable, costly, and not practical. It also differs from Alberta's own Directive 17, and companies have been relaying these comments to Alberta Environment Parks. Method 3, fuel consumption based on internal facility metering or third-party invoicing. These are for fuels not reported in Petronex. For example, a third-party supplier of diesel, propane, or gasoline who internally meter themselves or provide a third-party invoice. Stationary fuel combustion provides the heat or emissions for industrial, commercial, or industrial use. Examples may include a boiler, an engine, a turbine, but the source category doesn't include the flare or waste incineration sources, except for the fuel gas used as pilot gas or fuel used in the incineration process. And the methods discussed in this part of the chapter deal with variable and non-variable fuels and are based on either the default emission factor, the high heating value correlation, or the fuel gas carbon content. For method 4, the carbon dioxide based on default fuel gas emission factor, This method is for individual COGs with emissions less than 10,000 tons, and it's used for fuel gas volumes calculated using method 1, or the fuel reported in Petronex. The CO2 emissions are calculated using a single fuel gas stream and default emission factor shown in table 15.3 using equation 15.4 shown here. And the COG must apply this methodology for both benchmarking and compliance reporting. Table 15.3 shows the default carbon dioxide emission factor, as well as the default rich gas composition and higher heating value. If the COG would like to apply gas compositions or higher heating values to calculate their CO2 emissions, but doesn't necessarily have the required composition or higher heating value data for benchmarking, the facility can then apply to use a default sales gas emission factor for the benchmarking period. And similarly, if the facility would like to use a default sales gas emission factor and would like to change from using methodologies using the default CO2 emission factor, they can do so as well if they are missing the required composition or higher heating value for the benchmarking period. And if so, table 15.3 also contains the default sales gas emission factor, the sales gas composition, and default higher heating value. Method 5, the CO2 emissions based on default emission factors for non-variable fuels reported in Petronex. These are for fuel volumes calculated using method 3. The chapter reiterates that on-site transportation emissions are not included as stationary combustion, not included in that category. And the CO2 emissions are calculated using either a measured or supplied higher heating value using equation 15.5 or a fuel-specific default carbon dioxide emission factor from table 4 using equation 15.5. And table 15.4 lists the emission factors for non-variable fuels and listed either on a volumetric or energy basis. Method 6, the carbon dioxide emissions based on high heating value correlation, consistent with ECCC's greenhouse gas reporting program. This method is for use with fuel volume calculations and compositions using method 2, and CO2 emissions are based on measured higher heating value using equation 6. This method would be ideal for companies where the fuel is supplied on a volumetric or energy basis, and the higher heating value is readily available by the third-party supplier. For method 7, carbon dioxide emissions based on fuel gas carbon content. This method is based on a mass balance approach using the fuel carbon content. It is for fuel consumed as calculated using method 2 or method 3. The carbon content can be measured by the facility, excuse me, or provided by the supplier. And for gaseous fuels where consumption is measured by volume, you can use equation 15.7, or if the consumption is measured on an energy basis, you can use equation 15.7b. For methane and nitrous oxide emissions, methods 8 through 9 are applicable to all COG facilities, and they are based on either the fuel itself, sector-based variable fuel, or technology-based variable fuel. I think someone may not be muted.
Someone has their mic on still in the background. Appreciate if you turn it off. Thank you.
Thank you. For method 8, non-variable fuel emission factors, the chapter lists table 15.5, and it's quite straightforward, and that the table lists methane and nitrous oxide emission factors for various non-variable fuels. With the caveat, though, that if an equipment inventory is not available, the responsible person must apply the tier 4 emission factor for diesel fuel. And for their inventory of gasoline equipment, they must apply the 4-stroke engine emission factor for gasoline sources. For method 9, variable fuel sector-based emission factors. For variable fuel like natural gas, the simplest approach would be to use the methane and nitrous oxide emission factors emissions quantification. The simplest approach for methane and nitrous emissions quantification is to apply method 9 over method 10, as you can simply apply the emission factor to the fuel volume or the energy content. And this would be ideal for facilities with less than 10,000 tons, as you can streamline the approach, but any amount under 100,000 tons can use method 9. Method 10, variable fuel sector-based emission factors. The COG may consider using technology-based emission factors in the table shown here if more accurate emissions are warranted, or if the emissions for the COG are approaching the standalone reporting threshold of 100,000 tons. This method may be cumbersome though, as the fuel or energy content must be allocated or metered to the specific technology types. For methods 9 and 10, the following selection criteria apply. The COG must apply either method 9 or method 10 to equipment within the facility, and they must consistently use that method for both benchmarking and compliance reporting. And for method 10, they're required to use the same emission factor for both benchmarking and compliance reporting, unless different equipment is present. For example, an uncontrolled NOx boiler is present during the benchmarking period, and during the compliance period, they made an upgrade, and now the boiler is NOx controlled. Method 11, Petronex production volumes. The aggregate facilities production volumes quantified and reported under tier will be the volumes reported in Petronex for each COG. The volumetric emissions must identify the activity, the product, and the associated volume, and these volumes will be used for the quantification under tier. If the COG has no volumes reported in tier or believes the reported volumes in Petronex are not reflective of the actual production volumes for their company, it is recommended that the responsible person contact the director for further direction. The responsible person for an aggregate facility may request a benchmark unit for the aggregate facility using one of two options. They can request to use the following benchmark units for specified energy products, either production, dispositions, or receipts. Or option 2, they can propose to use an alternative benchmark if option 1 isn't applicable. However, in the interest of time, we will only discuss option 1 today, though the draft document does go into detail on how to develop an alternative benchmark. Once a benchmark has been selected, the volumes associated with the benchmark unit are determined using equation 15.9 and 15.9a. And the conversion factors associated with the benchmark unit are listed here in table 15.9. A benchmark unit requested from method 11 will be evaluated by the director as part of the facility-specific benchmark assignment process based on the following criteria: whether the benchmark achieves a strong month-to-month correlation with the aggregate emissions, whether the benchmark minimizes variability of month-to-month emission intensities, and whether it represents the composition and operation of the aggregate facility. Here is an aggregate facility timeline example. During 2020, the benchmark applications, while originally due this September, have been delayed to 2021. And additionally, the benchmark reference year was 2019 and has been updated to 2020. In 2021, the compliance and benchmark reporting will be due, and the reduction target for the aggregate facility is set at 10%. So the compliance obligation is set at 90% of historical emissions. And as I mentioned, the benchmark reference year is set at 2020. In 2022, the benchmark reference years will be the average of 2020 and 2021. And 2023 and beyond, the benchmark reference years will be the 3-year average of 2020 to 2022. So while there's no benchmark or compliance reporting for this year, now would be a good time for companies to complete their emissions projections, estimate and budget for compliance costs for the 2020 compliance year. And additionally, companies is recommended to use this time to ensure that they have the appropriate data, the records to support the quantification and the production for their sites for 2020. They should review and decide which benchmark unit will best represent their aggregate facility. And they should have consideration for sites that are over and under 10,000 tons of carbon dioxide equivalent and their choice of methodologies. That's the overview I have today for tier aggregate facilities. Some additional resources listed here include a link to Alberta and Environment and Parks tier regulation website, a link to the draft quantification methodology document, and a link to the comment form for the draft quantification methodology. Any questions today?
Thank you very much, Anthony. That's very interesting and very helpful, detailed review of the methodology document for those who are on the line and who might be considering this. If anybody has any questions, I encourage you to please type it into the GoToWebinar platform, the questions box. I'll start with one, Anthony. What type of uptake are you seeing, or if it's too early, what type of uptake do you expect to see for these aggregate facilities to opt into the tier regulation program?
Well, AEP doesn't necessarily publish that information publicly, but I would suspect that based on the cost example, based on the federal program versus the provincial program, what we're seeing for medium to large size companies, there's approximately a 10-to-1 difference in what you'd have to pay in terms of the fuel charge. And so I would expect many companies who have medium to size fields or fleets of facilities to want to opt in. I couldn't necessarily a number, but it would be definitely in their favor to opt into the program.
Thanks, Anthony. Yeah, the cost comparison that you illustrated at the early end of your presentation was quite stark. There are no specific questions that have come in, but it might be due to the very technical nature of your presentation, Anthony, and the detail that you provided. I'm sure you'd be happy to take any questions that people might have offline, and your contact information is noted on the screen. Thank you very much, Anthony, for your help and your time. Much appreciated.
Thank you very much to yourself as well.
Terrific. Well, with that, we'll switch gears and we'll see if we can get Jeff's audio working. As I had mentioned a little bit earlier, Jeff is at Tree Time Services, and we've heard from Anthony and Brody about different types of emissions into our natural environment. Perhaps Jeff can give us a bit of on-the-ground observation about how that might be affecting reforestation. Over to you, Jeff.
Yeah. Can you hear me?
Perfectly. Thank you.
Oh, great. Yeah. So as mentioned, my name's Jeff Renton. I'm a forester who has technology issues, quite a few. But anywho, so I'm a reclamation coordinator at Tree Time Services, and we do. This is a little bit technical in terms of the information that I'm providing. There's about half of it is background to kind of explain the context of some of the toolkits that the tools and strategies that I'm looking to provide. And some of the background is a bit stark in terms of the actual significance. But I do like how this presentation wraps up in sort of some of the potential solutions. Right, and just to quickly review kind of what I'm looking to talk about is to give an idea of what have been the changes in climate and what are some of the anticipated changes in climate and weather, and how that's going to affect plant survivorship and plant community composition, and sort of allow that to flow into the reclamation context. What can we do to increase the successful reforestation of these reclaimed sites? And why am I talking about reclamation sites? Well, and why am I talking about increasing seedling survival? So seedlings are a lot more vulnerable to environmental stressors than mature plants. They have a much smaller root system, and they also exist in the area, so 30 centimeters above and below ground, where there is substantial change even within a day on temperature and moisture levels. And so with their decreased tolerances, but also in a very stressful area, they face a lot of challenges. But also in a reclaimed area, a lot more challenging than in a natural area. I'll provide a bit more context on that. As well as in the future climate, they're going to have a much more difficult time establishing and being productive. So one thing I think is really important to understand when trying to think about what kind of change can we expect is how much change has actually already happened. So since 1948, the global temperatures, average global temperature has already increased between 0.6 and 0.9 degrees Celsius. And in the prairie provinces, 1.9 degrees average temperature has already happened, right? In terms of where are we looking, where could things what could the amount of change be? Well, there's going to be a greater variability in that because we don't totally know. There's a number of models that give us a range of in Canada between 1.8 and 6.3 degrees Celsius. And winter temperatures, it's an even starker contrast, where we're looking at 2.5 degrees to 10 degrees Celsius change. And that can be a difference of whether we might not have snow. Edmonton, for instance, has an average temperature of 3.3 degrees Celsius. And so looking at, well, what if we go to 10 degrees Celsius, or sorry, 1.8 to 6.3 degrees Celsius? That's a pretty big change. And I guess to also provide a bit of context of, yes, we have had warmings before, or changes in temperature in this scale. However, the period of change in the past several million years, generally that a warming of 5 degrees has taken over 5,000 years to happen. Right now, we're looking at something similar to that, or perhaps more, in less than 200 years, with what I would say is ecosystems that are far less intact than they would have been under previous changes, and those ecosystems can help buffer that change. But they're able to, with that buffer, they're able to adapt over a longer period. But under a very short time constraint, it's very hard for them to adapt these significant changes that we're anticipating. And a little bit more on sort of what amount of change we can expect in the future. In the graph on the right-hand side, there's three emission scenarios that based on a low, medium, high. So from blue, low, and high being the red. And as you can see, as it goes further out into the future, there's a lot more variability just due to uncertainty. But even at the solid bars, it's predicting quite a bit of change. And in terms of where do we see where would we end up? Because it's hard to really base this on things that are maybe uncertain or lots of policy decisions, but basically the closest scenario to where we're headed is the RCP 8.5, the red bar. That's a little bit more in line with the amount of emissions that we currently produce and are likely to produce into the future. And so this is global average temperature, I should mention. So in Canada, it tends to be a bit higher due to a number of factors, but we are looking, based on our current trajectory, we are looking at a significant increase in global average temperature. And coming back to the Canada context, so this shows a little bit in terms of the geographical variability of the increase in temperature that we can expect. So the one on the left is on the lower end, the one on the right is on the higher end, so the red bar that I was speaking to, which is sort of where we're on trajectory. And looking at Western Canada and even in the north, it's a lot more significant. We can see a potential of significant temperature increase, and that's going to affect quite a bit it's quite a difference from the plants, how they're like the environments that they were adapted to. Now, I've just really been talking about climate, right? And so what is climate? It's the average of temperatures and precipitation, right? And so the average, what happened in a day, what happened in a week, and so that there's a lot of variability in that, and I've just been talking about the averages. So what is going to happen is that the numbers, the weather events that make up that average are going to be a lot further from the average. So you're going to have these extremes. So extreme in heat waves, extreme in cold snaps. Like for instance, Edmonton currently on average has about 3.8 days above 30 degrees Celsius. that in the next 60 years is going to increase between 16 to 26 days above 30 degrees Celsius. And as mentioned, increased cold snaps. The intensity of precipitation is going to increase. From what I've seen, the amount of precipitation isn't going to increase significantly, or isn't going to change significantly, but the intensity of the events is going to. So these extremes are actually the predominant factors that shape vegetation communities. Averages. So climate has a pretty significant role, but there's a lot to speak to. The actual changes in vegetation communities are the extremes, and as we see more of these extremes, as we have seen more of these extremes, plants are going to be further stressed. And sort of how does that affect plants, right? And so plant phenology, that's the timing of life cycle events. They're adapted to both climate, weather extremes, and photo period, the day length. And so that day length is traditionally been linked fairly much to the seasonality in the climate, and they function as part of that. And so plants, some are more adaptable to changes than others. Some are a bit more tolerant like they're more tolerant to the stressors that come when weather events are out of sync with traditional climatic patterns. But others are more able to respond to changing their timing of events to weather. And so the thing is, though, regardless of, because, well, one is we don't know how much change is going to happen yet, but when plants find that their phenology falls outside of these traditional patterns, that weather events can really significantly disrupt, whether it be development of buds, putting on new foliage, putting on new shoots, going into dormancy. And when that happens, you can have loss of plant health. You can have plant dieback, you can have total death of mature plants, and you can have actually significant change of plant communities if these changes in weather and climate are significant and take place over a longer period. A little bit of background sort of in how plants are adapted to their local conditions, and how that actually has some genetic aspects to it. And so this is the seed zones in Alberta, and sort of just from a basic element is these are biogeoclimatic zones where, for instance, a white spruce from one area one of these areas is going to be somewhat genetically dissimilar from one of the adjacent zones, and it's based on the climate in the area. It is somewhat genetically adapted to this area. So if I was looking to, for instance, deploy white spruce in the top darker green seed zone, the seed would have had to have come from that area. So this is actually legislated. I mean, this is just for public lands, but the idea is that spruce its genetic material is adapted to that specific area. So that does create limits in case we're looking at moving things in anticipation of future climates. Now, looking at how does that all come down to a reclamation site? So a lot of what I've spoken about is more just looking at things from a natural perspective, right? So what happens, with natural succession, natural regeneration. In a reclamation site, there's different makes and models, right? There's different amounts of preparation that have happened, different amount of how long events have happened. But in a lot of reclamation sites compared to natural sites, significant things, there's less shelter, so there's less roughage on the surface. Wind can move a lot quicker, things can dry out a lot quicker. There's less organic matter, LFH layers, so there's a little bit less moisture holding capacity. More competition for seedlings, so there's going to be less light, nutrient, and moisture available for seedlings, and as well as these are often more compact than the natural sites, meaning it's harder for a seedling's roots to spread out and get the moisture and nutrients that they need to survive. Now, that's sort of the background in terms of what are some options to to increase the survivorship, the likelihood of reestablishment of vegetative cover. One thing I want to highlight is that, there's, as I mentioned before, there's not a lot of certainty in terms of how significant the change is, and so none of these are going to be we can guarantee. However, a lot of these methods are things that myself, my colleagues, colleagues in academia and industry have been employing for a number of years in stressful sites that have a lot of the traits of where we're kind of looking at things might end up climatically. And so I would say that these are a pretty good bet against working in a number of the scenarios that we're likely to encounter. One interesting one I like to start at is sort of biodiversity, right? And I remember in school, like this was a good thing, but it was never totally explained where the benefit is. It's just more species, more redundancy. But this is a really good example of highlighting the importance of biodiversity. So if this picture here, like you can see a number of species were planted here, and just understanding the basic element of different species have a range of environmental tolerances, whether it be on moisture, on drought, on precipitation intensity, and they're all going to have their own different tolerances. And by having multiple species, you have a wider breadth of tolerances. And hopefully, if we're in a site that is very stressful and it's very exposed, you will have at least one of those species that are going to fall in with what actually happens. So also genetics is a pretty important one. So I already kind of alluded to that one with the seed zones. And so as mentioned, there's a bit of a limit in terms of how much you can move a genetic material, although you can get permits with appropriate justification for moving between adjacent seed zones. The other interesting thing too, I find, is that there are a number of species that are a little bit, their timing of their life cycle, their phenology is a little bit more linked to climate than it is to day length. And so, for instance, trembling aspen, balsam poplar, white birch, beaked hazel, they're going to be a little bit more responsive to what's actually happening, and so they might not have bud flush until it's much warmer out, for instance. And so using more of those species can be quite helpful. One interesting tool that we have at our disposal is use of improved seed. So over a number of decades, there has been breeding programs of various conifer species throughout the province, from using material from multiple seed zones, and it's allowed seed to be adapted to these multiple seed zones and thus likely have a much greater sort of environmental range of tolerances. The picture in the center is of region I white spruce. And so its range of deployment, and the blue lines are the seed zone boundaries. And so looking at this, like, it can be deployed over a much wider area than just one of these seed zones. We grow quite a bit of improved seed. It allows us to be a lot more flexible in terms of what's going to happen year to year, because we don't want to just, if we're doing growing speculation stock, we don't just want to rely on knowing for sure one seed zone is going to be in demand. By growing more of this improved seed, we can be a lot more flexible. Now, site preparation is also very, very key, right? So this is going to help a lot with removing site limiting factors that may exist with the site. One of the sort of key elements is creating these microsites, these small sheltered areas that reduce stressors on the seedling, whether it be from desiccation, or they can also increase moisture levels in the soil. And another example of the first page is by spreading coarse woody debris. And I like the two pictures in contrast. Of the one in the center is a really good example of spreading the coarser wooded debris, as opposed to the more broken down on the right-hand side. So you can see that the seedlings provided more shelter from the wind, and also this is a good place for snow to capture, for rain to settle in and increase the local soil moisture levels. Also, these microsites can be created by soil movement. This is a piece of forestry equipment. Traditionally in oil and gas, an excavator is used to create mounds. Often mounds are done more for creating that relief in wetter sites, but it can also be used to remove competition, remove compacted soil, depending on how deep the compaction is, and removing organics to allow planting directly into mineral soil. In this context, looking at the diagram on the left, point number 2 is where we would be planting seedlings. So the mound on the left provides a bit of that wind protection, and the depression, number 3, provides a place for rain to collect, infiltrate into the soil, and increase soil moisture levels overall. So this is something I've done a lot in the reclamation context, and find it's quite effective. As well as coming back to removing competition. I really like these 2 pictures contrasting it, because up until in my early days in reclamation, I was always just looking at, the grass is, all right, that's mostly light competition. And with the snow press, as snow will press tall grass onto seedlings and hurting them, I think about those are my main issues. But sometimes when it's important to think below the ground, how significant is the sod mat? Do I have a sod forming grass? And looking at that area, that's almost total overlap with the seedling plug. And so something with a very small individual dealing with, with a very established root system is quite significant in terms of threatening the overall health of the seedling. So removing sod is very, very, very important. Reducing compaction, as I mentioned before, is very important, because thinking about, some sites, it's they can be quite compact, and thinking of if it's challenging to put a shovel in the soil, how difficult is it going to be for a seedling to push out its roots to obtain moisture and nutrients. Also, one other thing is it by breaking up the soil, especially in finer textured soils, that allows increased infiltration of water. And planting design. So this is where it can get a bit tricky, and it's going to depend a lot on the knowledge of the person designing the planting, but also the actual planting contractor, because these can get a little bit more complex, and there's a lot more handling and management involved. But in these sites, depending on how variable they are, how large they are, planting, for instance, conifers in more sheltered areas, especially where snow cover is likely to be lost multiple times during the winter. This is where a lot of the foliage, even though it's dormant, it can still become desiccated over the winter. And I was just at a site in the Calgary area where they planted a number of conifers, including Siberian larch. This was public land or private land, and it's near Calgary, right? So not a lot of snow cover in the winter, and the only seedlings that really survived were the Siberian larch. They dropped their needles, and then they grew them back in spring, and they were doing quite well, whereas in the pine and spruce were actually in very poor shape. But that is more for that's a very stark contrast in the Calgary area as opposed to a lot of our planting areas. Whereas as mentioned, planting deciduous and exposed areas. So if we're dealing with a fairly exposed bluff, putting in deciduous where they don't have foliage that needs to be protected over the winter, that can help quite a bit. That said, in some areas where it's just going to be stressful and there's not a lot that can be done to ameliorate that, there may be higher rates of mortality. Putting in a higher density to ensure that we're getting that minimum number of stems is also an option. Lastly, the timing of the project implementation, I think, is going to become a bit more important. Syncing in project activities like soil placement, site prep with planting, so to reduce the chance of competition coming in, for instance, is of I would say greater importance, because as climate is going to become more stressful, we need to ensure that we're having limited competition as much as possible. One other one, I think it's the last one, is it's always been important, but I think it's going to be more important, is like comparing summer deciduous planting, so broadleaf planting, to spring. So spring, we're putting in dormant seedlings that have no leaves, And so when you plant them, the leaves are growing the same time as the roots. And also it's generally not as hot as summer. Whereas in summer, we're planting leaf-on deciduous, and it's also a lot hotter. So in summer, you have these large leaf areas, you have a higher evaporative demand with higher temperatures, but still that small root mass that's just starting to grow more. And so desiccation can be a lot higher, especially where we'll think about Edmonton, or once again, where we're talking about days over 30 degrees going up at least 4 times than they are now. That's what can cause a lot of die-off of deciduous plantings. So planting more spring if possible, or being a lot more strategic with when you plant in the summer, a lot more flexible when you plant in the summer deciduous species. So yeah, to sum it all up, it's important to understand that climate has changed, extreme weather events have changed, and it's going to continue to do so. How so? We don't know, but it will be changing significantly regardless of that. And with that, we're going to have plants that are adapted to a fairly consistent range of environmental factors, risk falling outside of that, and whether or not it's loss of productivity or loss or complete change of environments. So by getting, the importance is to get seedlings to maturity where they're able to tolerate these changes is really important. And so we have a lot of things, a lot of options to work with. And I would encourage anyone that's just interested in just shooting some of these ideas with us, feel free to call myself or anyone at Tree Time. This is a type of conversation we love having, because it's obviously not just a cut and dry situation. There's a lot of judgment that comes into this, and it's very challenging and also very interesting. So yeah, number of references. And so if anyone has any questions, feel free to, specifically on the technical elements, feel free to, ask me now or email me on it. And otherwise, I appreciate everyone participating in this presentation.
Thank you, Jeff. Really excellent, and visuals provide a really helpful way to understand the different concepts that you're talking about. To anybody who has any questions that they'd like to share in this forum, please feel free to type them into our question box. If not, of course, reach out to Jeff directly. Jeff, I'll ask you a question. When you work on a site, how much follow-up do you have with the site after you've implemented the different strategies that you've talked about? How long do you track the site?
So it depends on the client. And so some of our, usually where we do track sites, it's just 1 year. We're us specifically. So in the forestry context, we do provide support, and a couple of our staff, the year of planting, we fly with majority of the forestry companies in the province and look at how sites have fared based on site preparation techniques and the stock that we've provided. And then those sites then go on through various legislative surveys, and we are able to kind of find out how things have been going on the long term. However, in the reclamation context, there are some times where we are contracted to do some follow-up, but we don't often get to see how significant the changes have been. In some cases, it's just been sort of no news is good news, in that our clients that do the DSAs the sites have passed, and they haven't really spoken to us about it. But yeah, but that said, with some of the things we do track because we're very interested in, like the mounding, some of it we just take as a personal sort of professional interest, and the mounding has been very effective in some very stressful areas.
Thanks, Jeff. We do have one question from our audience. The question is, has there been any occurrences in your memory where a site couldn't be reclaimed, the damage was too great?
So there have been sites that needed to be redone, right? So in some cases where maybe the mounding wasn't done appropriately, and the mounds weren't broken up, and so it was a clay soil, and the clay, the mounds just hardened into a sheet, and it couldn't be broken with a shovel. There's been situations like that where it's just maybe the prep could have been done differently, and sometimes sites have to be redone. In terms of, is a site impossible to reclaim and the damage is just permanently too substantial? I haven't come across that. And I've seen, just even in university on some research trials, some pretty impressive degradation. Sometimes, and it has been reclaimed. I find it's just been, they just need to be redone in some cases.
Very helpful. Well, thank you very much, Jeff, for your time and for your responses to our questions. Really appreciate it. And with that, we'll transition over to Danny.
Cool, thank you.
Terrific. As I make the switch here, Danny's at Vertex Resources Group, and just as we started on the topic of methane, and Brody talked to us about his company and their methane monitoring, Danny's going to give us a little bit more on the compliance side, and specifically, how to apply a strategic approach to complying with both federal and provincial methane reduction regulations. So Danny, look forward to your speech. Over to you.
Hey, Danny, it's Joey. On your screen there where it says display settings, if you click swap presentation view, we'll be able to see your presentation. There you go.
Thank you. Sorry about that.
No, it's okay. It's all new for all of us.
Perfect. So you can see my screen okay there?
Yeah, you sound good. Thank you.
Great. Thank you. So good morning. My name is Danny Urton. I'm with Vertex Professional Services. Thank you very much to Joe and Isa for having me on today and for making everything run so smoothly. I'll be discussing the concept of strategic compliance with provincial and federal methane emission reduction regulations. So I'll begin by discussing the background behind the provincial and federal regulations and how they apply to the Alberta upstream oil and gas industry. I'll give an update to the status of these regulations and Alberta equivalency, since there have been some recent announcements about this. And I'll also go through the current suspensions that are in effect due to the COVID-19 pandemic. I'll run through a high-level overview of the methane reduction requirements that are currently in effect under both the provincial and federal regulations. And then I'll move into an in-depth comparison of the fugitive emission management requirements under both. I'll be discussing some of the challenges that come with these regulations, particularly with the uncertainty surrounding dual regulation, upcoming equivalency, and the current industry environment. And I'll discuss a few strategies for compliance in light of these current circumstances. So before I begin, I'll just make note of the fact that anything I say today is my own interpretation, and any operational decisions should be made with reference to the official regulatory communication. So this is just a presentation to outline a few strategies to deal with the challenges of working in this evolving and uncertain regulatory environment. So just a quick overview for anyone who's not familiar with the methane regulations. Both the Government of Canada and the AER published new regulations for oil and gas producers, which have a number of methane monitoring and emission reduction requirements. And this all started with Canada's commitment to reduce methane emissions from upstream oil and gas by 45% from 2012 levels by 2025. So in April 2018, the federal government released its methane regulations, applying to all provinces as of January 1st, 2020. Under the Canadian Environmental Protection Act, provinces can choose to develop their own regulations to replace federal measures as long as they can demonstrate equivalent results. So the AER responded by publishing updates to Directive 60, Directive 17, and supporting manuals 15 and 16 in December 2018. Which also went into force as of January 1st, 2020. And in May of this year, the AER made some further amendments to Directives 60 and 17, increasing stringency for certain requirements as part of its equivalency negotiations with the federal government. So at this time, the AER has received draft equivalency approval for its methane regulations, and I'll discuss that a little deeper in the next couple slides. So the process for obtaining equivalency from the federal government for provincial regulations is quite prescriptive. The federal government can enter into an equivalency agreement with a province if it deems the provincial regulations to be equivalent. And as part of this process, a draft equivalency agreement is published for a 60-day public comment period. After that, the federal government issues a formal order declaring that the federal regulations no longer apply within the provincial jurisdiction. So the point of this process is to minimize the duplication of environmental regulations, which is the situation we've been working in Alberta since both provincial and federal regulations went into effect as of January. So I'll be focused specifically on Alberta today, but I've also included a couple notes about BC and Saskatchewan here. So BC has already gone through this regulatory process for equivalency, and within BC, oil and gas producers are only obligated to comply with BC's provincial methane regs. Both Saskatchewan and Alberta have had their draft equivalency agreements published on the CEPA registry, and they're both currently within that 60-day comment period. So the importance of this is that until the final equivalency agreement is published, and until the formal order to stand down federal regulations in the Alberta jurisdiction has been issued, we'll still be working within a dual regulated environment. And looking at BC as an example, the time between publishing the first draft of their equivalency agreement and the formal standing down of the federal regulation in BC was about 12 months. So with that in mind, it's important to be aware of the obligations and deadlines that exist under both frameworks until that equivalency has been finalized here in Alberta. So just to add another layer to this complicated regulatory scenario, the AER has issued ministerial orders and legislation in the past couple months as part of its relief for industry during the COVID-19 pandemic, which has temporarily suspended some requirements for fugitive emissions LDAR programs. And I'll get into this in further detail as I talk about provincial requirements. But these suspensions are in effect until otherwise announced. With respect to federal regulations, the Government of Canada announced at the end of May that any LDAR monitoring that would result in a serious risk to human health or safety is not required at this time, but that any non-compliance with a regulatory program should be documented. So with that said, any LDAR that can be conducted within the restrictions of physical distancing and other public health guidelines that are in place would still be required. So interpreting these communications can be challenging, particularly with the federal communication, which is not definitive. So I'll take these suspensions into consideration when I give some recommended strategies for compliance following a comparison of both the provincial and federal regulations. So with dual regulation in mind, I'll run us through a comparison of the requirements under the Alberta regulations and the federal regulations to show some ideas for strategic compliance with both. So this slide shows a high-level list of some of the categories of emission limits and monitoring requirements that are required under both the provincial and federal regulations. They were both developed with the same goal to reduce methane emissions, but from an operational perspective, there are some major differences. So the AER's regulations were developed specifically related to operations in Alberta, while the federal regs had to be developed to apply across the entire country. So both regulations have specific requirements for venting equipment, although the specific details and vent gas limits vary between the two regulations. So this needs to be considered when building out a compliant methane program. It's also important to make note of some of the vent gas limits that were updated in the new changes to AER Directive 60 and 17 in May of this year. But this presentation today will be focused specifically on fugitive emissions and LDAR. So I'm going to run through the main differences between the fugitive emissions requirements under the provincial and federal regulations. From an operational perspective, some of the main differences between these regulations include the party responsible for the execution of a field LDAR program, which facilities are in scope, inspection frequency requirements, approved methods for inspection, the definition of a leak and repair requirements, and the reporting, registration, and record keeping requirements. So after I outline these main differences, I'll provide some suggestions for running a program that's compliant under both, since producers will have to account for the requirements of both frameworks until equivalency has been finalized. And at that point, fugitive emissions management programs can be scaled back to comply just with Alberta methane regulations. So both regs define who is responsible for the execution of a field LDAR program and who's responsible for reporting and record keeping. So the AER indicates that the duty holder is ultimately responsible for executing fugitive emissions surveys and screenings, while the operator of record is responsible for reporting all emissions data. This is particularly important when it comes to facilities that are licensed and operated by two different companies. So in these cases, the responsibility for fugitive emissions monitoring might be outlined in the individual operating agreement for that particular site. But either way, the fugitive emissions data has to be reported by the operator of record in the annual methane emissions report that gets submitted to the AER. Under the federal regulations, the operator is responsible for carrying out the LDAR program, and that includes record keeping requirements. So having a clear understanding of who's responsible for fugitive emissions management will allow producers to identify the list of assets that are in scope for their own LDAR program. When considering the approved methods for inspecting facilities for leaks, the AER's regulation provides for a lot more flexibility at certain sites and for certain purposes. So under both frameworks, an optical gas imaging camera can be used. You'll see here, I put an image of a FLIR GFX 320 camera. This is what Vertex uses for LDAR surveys. It's also referred to as an OGI camera. And the tablet to the right is an approved quantification technology that works with the camera. This is a QL320 device from FLIR, which uses the OGI video from the camera to measure the rate of emissions. Another approved method under both frameworks is EPA Method 21, where a portable instrument is used to detect leaks from individual equipment components, and it reads the concentration of hydrocarbon gas from any leaks identified. So the federal government requires that all inspections be conducted using one of these methods, but the AER regulation permits the use of different methods for screenings at well sites. So screenings methods can include SOAP solution or SNOOP or AVO methods, that's audio, visual, or olfactory. So the fact that operators can conduct their own screenings under the AER framework significantly reduces the cost associated with inspecting well sites when comparing regulations. Another important note about AER screenings versus surveys is that within the Alberta Energy Ministerial Order from April 14th, the first two surveys for facilities which would require triannual surveys under Directive 60 can be replaced with a screening until otherwise announced as part of Alberta's COVID-19 relief measures. So this will be an important consideration when looking at effective strategies for compliance in 2020 specifically. So I've included this slide just to show the difference in definition of a leak under each regulation. And this is important when we consider repair requirements. So under both frameworks, the responsible party has 30 days to repair any leaks identified during an LDAR survey, with some exceptions. These repairs then have to be re-inspected or verified within 7 days. The requirement to repair leaks within 30 days has also been temporarily suspended in Alberta by the AER as part of the COVID-19 response, with the exception of leaks that have the potential to cause safety hazards. The federal regulation indicates that a leak is considered to be repaired when any remaining release following the repair has a concentration of less than 500 ppm hydrocarbons, measured using a Method 21 instrument. So the AER does not prescribe a method for verifying repairs, which gives operators a lot more flexibility. So I'll come back to this when I discuss potential strategies, taking into consideration the fact that we're expecting equivalency sometime in the near future. So the required frequency for LDAR surveys also varies under the two regs. The AER requires one fugitive emissions survey per year at most active facility types, and 3 surveys per year at certain types of facilities like sweet gas plants, sweet compressor stations, and sites where there are controlled storage tanks on site. At well sites, 1 screening is required per year. And again, these can be fairly easily completed in-house by the operating company as part of a standard site check. The federal regulation requires that all facilities and well sites that are in scope undergo 3 surveys per year using either OGI or Method 21. So in scope under the federal regs is any facility or well site that produces or receives a combined volume of 60 decks of gas per year. The only exception is well sites where there's only a wellhead and a meter or some gathering pipelines on site. So operationally, these different frequency requirements can make a significant difference when planning an annual program. In my experience, I've seen the number of required surveys under an AER compliant program increase from double to tenfold when including all in-scope facilities 3 times per year under the federal regulation. And with the AER's current suspensions to triannual surveys and the federal government's non-application of requirements on a site-by-site basis, this difference could be even more significant depending on a producer's assets. So under both regulations, producers have the option to conduct an alternative LDAR program. So this is any alternative to the regulatory LDAR requirements. And some examples would be the use of alternative emission detection technologies like truck-mounted sensors, aerial flyover surveys, or satellites to detect emissions like what Brody with GHG SAT was presenting earlier this morning. Under both regulations, an alternative program has to show equivalent reduction with a regulatory program, which can be challenging because very few operators have the baseline data needed to prove this since these requirements are new as of 2020. So the reporting and record keeping requirements vary between the 2 regs. The significance of this is that it's important to have a clear understanding of what's required under each regulation to ensure that all the necessary data is collected in the field and to be aware of the different deadlines. So the AER regulation has annual reporting requirements for fugitive emissions and other methane venting emissions. For anyone who missed the June 1st deadline to report 2019 data this year, it looks like the AER has issued some late notices asking for submission before June 15th. So it's just something to be aware of. The AER also has some record keeping requirements where certain documents have to be available for audit upon request. The federal regulation doesn't have any formal reporting requirements, but it has significant record keeping requirements for LDAR inspections. The federal regulation also includes a requirement to register all facilities before April 30th of this year. Given the fact that equivalency was not yet issued by that time, all producers should have registered their facilities with ECCC by that time. So I've gone through a number of operational differences between the fugitive emissions management requirements under the provincial and federal regs. So I'll move into a summary of these challenges and how to move forward with the anticipation of equivalency and some solutions, just given the current state of things. So with the different requirements for surveys, screenings, and LDAR inspections under the 2 regulations, it can be challenging to create a comprehensive list of sites that need to be surveyed. So a solution for this is to run through an assessment of your asset list and the different inspection requirements at each site. Since we're almost halfway through 2020 now, as part of my recommendations here, I'll just assume that all operators were compliant with the requirements of both regulations for the first round of surveys, and that we're just looking forward to the remainder of the year. So federally, the 2 remaining triannual surveys, and provincially, the remaining annual or triannual surveys and screenings. So as I mentioned, as part of Alberta's COVID-19 response, there is currently a suspension to triannual surveys where the first 2 surveys can be replaced with screenings. But sites which require annual surveys will still have to be inspected for leaks in 2020, along with the 3rd triannual survey. So taking this into consideration and comparing with the federal requirements, operators can create a priority list of sites that would have to be surveyed under both frameworks and start with those sites. This approach also allows operators to avoid conducting surveys that would not be required if the AER does receive that final equivalency approval in the next couple months. Another challenge that aligns pretty closely here is deciding on good timing to conduct that second round of prioritized surveys on those sites that would only require triannual inspection under the federal regulation. In this case, it really depends on the operating company's risk tolerance. This phase of surveys could be pushed back a little closer to the end of August, giving us a little more time to wait for that equivalency finalization. It'll also be important in that time period to keep an eye on AER announcements regarding the current suspensions, as they have recently announced that these suspensions might be adjusted to align with the direction of the stage 2 relaunch, which is starting tomorrow in Alberta. So this phased approach of scheduling sites based on current requirements can be a good strategy to remain compliant while also giving producers the best chance to avoid unnecessary work and expense as requirements continue to evolve. So we saw that both regulations have different reporting and record keeping requirements. This can cause challenges in knowing what data needs to be collected in the field. So a strategy for maintaining data effectively and managing what you need to collect is to develop a compliance-based data collection template for field crews to collect everything necessary for compliance with both regs. Another option is to consider working with a software provider who has a mobile platform or app that aligns with these record-keeping requirements to streamline the process of collecting data in the field. And in addition to emissions data, there are some equipment inventory requirements under both regulations. So in order to ensure that you have everything you need and to avoid duplicating work, going through your current equipment inventory to assess where any gaps might exist can allow for a short list of equipment inventory to be collected while an LDAR crew is already out in the field. So I briefly mentioned the option of conducting an alternative LDAR program. Under the federal regulation, repair verifications have to prove that any remaining release has a concentration below 500 ppm of hydrocarbons using a method 21 device. And doing this can essentially double the cost of an LDAR program, assuming there's one leak at each site, because you'd have to have a follow-up survey come back to verify repairs after they've been made. And the AER does not prescribe a method for confirming repairs. So a solution to create a program that aligns with both of these requirements would be to notify the federal government that your company will be using an alternative method for repair verifications only, using the federal alternative notification form. I also mentioned the challenge of assessing an alternative program that uses alternative technologies when lacking the baseline data needed to prove equivalent reductions. So a strategy for this would be to conduct a regulatory program in 2020 and then use the emissions and economic data from 2020 as a baseline to consider these options and if that's what would be the best for going forward into 2021. So one of the most obvious challenges with these new methane regulations is the added cost of compliance, given the current economic state of the industry. A few strategies for using resources as efficiently as possible are outlined here. So first, considering a collaborative approach with other producers, taking a look at other operators who have assets in the same area and planning to share resources, whether that be hiring the same LDAR vendor for the same trip or collaborating on an alternative technology investment. So at Vertex, we have a number of clients who have operations in the same areas. So we work under an area-based LDAR approach, similar to the way in which some producers are conducting site closures in Alberta. So this reduces the cost of mobilization, which can be a fairly significant portion of the cost when driving to all of the active facilities in the province. Another strategy is to take advantage of the fact that you've already hired a consultant to visit all of your active facilities to do LDAR surveys. And while they're out there, you could consider having that vendor collect equipment inventory that might be outstanding. And depending on the vendor, they might also be able to conduct other required emissions testing while they're on site, like annual compressor seal vent testing, the Sapper engine emission checks, or surface casing vent flow testing, gas migration, gas sampling. Again, depends on the vendor. They might also be able to support your required reporting if they have a strong understanding of the regulations. So this could reduce any duplicated work in managing your emissions data. Just a couple other thoughts on efficiencies. Given the 30-day timeline for repairs and the follow-up requirement to confirm repairs, we often recommend that an operator attend the LDAR survey with our LDAR technician to conduct any simple repairs while we're on site. So then our LDAR technician can just re-inspect the leak source while they're there and close out that leak right on the spot, saving time for the operating company down the road. Right now, while the requirement to conduct repairs is currently suspended under the AER's regulations, it's important to make note of the fact that this still remains in effect under the federal regulation for facilities that can be accessed safely. My final point is that these surveys will result in a large data set outlining emission reductions, and producers should take advantage of this data for internal purposes. So use this information as part of a sustainability report or public relations. The Alberta industry is making some big moves to contribute to a reduction in methane emissions, even during the significant economic stress happening in 2020. So we may as well use this data to further promote the sustainability of our industry. So that concludes my discussion. I'd be happy to answer any questions, and if you wanted to follow up directly, you can just reach out to me right there.
Thanks, Danny. Really interesting and quite a nice side-by-side comparison of the two programs. I encourage anybody who may have questions to please type them into the prompt in the GoToWebinar dialog box. I'm happy to start, and Danny, you might not wish to answer. I know it's only a handful of days old, but do you have any first thoughts on the equivalency agreement in draft? Have you had a chance to look at it, and how that might affect the regime in Alberta?
Yes, I have had a chance to look at it, and I do think it seems reasonable. Like I said, there haven't been changes made to the LDAR requirements that were originally published under Directive 60, but there are some major differences between some of the vent gas limits for equipment. Like specifically, the AER has requirements for glycol dehydrators, and the federal regulation does not. I think it's reasonable given that the AER regulations are intended to be specific to the way that we do oil and gas extraction in Alberta compared to across the country. So I have a good feeling about it. I looked at the analysis, and the AER regulations using the same methodology as the federal regs should result in increased reduction in methane compared to the federal regs. So I have a good feeling about it.
Terrific. Good to hear and good to know. I'll put out a last call for questions. Of course, I'm sure Danny, as she mentioned, will be happy to take any questions offline as well. But failing that, I'll say thank you very much, Danny, for your time and your preparation as you put that together. And before I put it back to Joe, I'll just take the opportunity on behalf of all of us who are attending to thank Joe and Isa once again for in these difficult and different times for taking the effort along with all the different sponsors to put this program together. So thank you guys very, very much.
Thank you, Anand, for a great job moderating. That was awesome. And thank you to the speakers. Very much appreciated. Thank you to all our sponsors. Couldn't do it without everybody and couldn't do it without all the attendees. So I usually would say, let's go to the buffet table, but we can't do that. So let's everyone have a break. We'll join back at, I believe, 12:45 for our next set of presentations. So thank you, everyone, and we'll see you back in a bit. Take care.